Hi there, here's a quick overview of the Chapter 17 notes that are on Compass and that you've had for quite a while. First part of these notes is parallel lines. You do need to know all the different names such as alternate and corresponding and co-interior angles. The more important information you need to know is how to calculate what these values of these angles are. For example, angles 1 and 3 are the same, which would be exactly the same as 5 and 7. Angle 1 and 5 are the same value. Things like 1 and 2, they're on a straight line, so they total up to be 180 degrees. The same with 1 and 4, those angles total to be 180 degrees as well. You may find parallel lines in questions using triangles or different shapes. For example, you may see parallel lines, which are always denoted using arrows on them. You may be given triangles in there, might be given this value here. You need to understand that that value is that value there. If we've been given other pieces of information, such as isosceles triangle, you can identify that value is there. You can then move on further to calculate the third angle in a triangle. There may be lines coming off that way, so you need to understand that there's parallel lines give you a lot of information about shapes given. Moving onwards to properties of triangles. So within triangles, we should know that the internal angle of a triangle is 180 degrees. As I keep on saying, if you've been given two angles, always calculate that third. If you've been given one and you can calculate the rest of the angles, calculate those. An example where you could calculate what all those values of the angles are in isosceles triangles. So isosceles triangles are denoted using lines like this. That means those two sides are the same. They also point to the same value of these angles. So if this value of this angle here is 10, that means this value over here is 10. And identifying this sort of information within triangles is very, very helpful. Once you've got that, you can then identify other pieces of information such as the third angle within that triangle. We also have in this triangle here that the values of B and A, so the two opposite angles within a triangle, equal the outside one there, so D. So A plus B equals D. You can also calculate D by, we know that this is 180 degrees. So the total of those two angles must equal 180 degrees. ED and F, which are the outside angles, must equal 360 degrees. And as I just said, isosceles triangles not on here, but identifying the properties of an isosceles triangle. Polygons. So these regular polygons here, you should be able to identify that a triangle is 180 square, the internal angle is 360, and then you could work your way up from pentagon, hexagon, and so on. If you're not sure how to calculate those just by memory, we have our formula here for the sum of the interior angles. If you want to know what one particular angle is, because all these angles are the same in regular polygons, so within each shape, each interior angle is the same value as the other interior angles, you can just calculate the sum and divide by how many sides you have. So the two formulas are given there for you. We can divide also regular polygons up into triangles and then calculate them as isosceles. These would be isosceles triangles within here. Remember that the center of a circle is 360 degrees. So we've got 1, 2, 3, 4, 5, 6. All these angles here would be 60 because 360 divided by 6 is 60 degrees. So each of these tips here of the triangles are 60 degrees. However, if this had more sides, so for example was 8 sides or even 5 sides, each tip of these triangles would be different values because, for example, a pentagon has 5 points at the center, so it would be 360 divided by 5. Alright, Pythagoras' theorem, c squared equals a squared plus b squared. Should be a common formula that you should be able to use and manipulate. For example, a squared equals c squared minus b squared, and b squared equals c squared minus a squared. Don't forget to take this square over and turn it into a square root when you're doing your calculations. Also know how to solve these for an isosceles triangle. So, for example, if we draw one in here, like this, and we were only given the hypotenuse, say of 20, solving for these, because with an isosceles triangle, we know that these two sides are the same. This would look something along the lines of c squared is a squared plus b squared. 20 squared equals x squared plus x squared. 20 squared would equal 2x squared, and so on until we solve for it. So joining these x values together, you can do that to solve for the x values. Now, moving on to similar triangles, if you watch part 2 of this flip, I will go on to similar triangles, volume and surface area, and calculate using the K factor for area and volume. Thank you.